Hello, folks. Welcome to this week's Aerospace Coffee Break series. My name is Wiley Abbott. I'm a technical account manager here at Altair, focusing on supporting the aerospace industry. My background is primarily in structural analysis and model build, but I do like to dabble in a little bit of TCL, a little bit of Python coding. And today, our topic for the Coffee Break series is the HyperMesh Python API. I'd like to spend a little bit of time talking about the way in which we've set up this Python API, compare it back to the classic TCL scripting methods that some of the classic users know and love. And then I'll jump into a demonstration of the API in HyperMesh, show some of the extensions that are available as well as some of the developer tools. And lastly, we'll take a peek at the documentation and show you all where you can find more information. Alrighty, so the Python API within the HyperMesh client, and I'll preface this with we have slightly different API for HyperMesh, Hyperview, Hypergraph. Each client has a different flavor of API based on how we're operating with different entities, different objects. On the left, so the collections, so a group of entities, as well as the database, these are now entirely object-oriented. So like all good Python users, we're thinking in terms of objects and collections of objects. On the right-hand side, we have what we call services. These are the actions in HyperMesh. Think of this as, generating a mesh or querying an element to find out its area, for example. So these services, they're more procedural in character, but they are now exposed as methods of the model class. This also enables you to utilize multiple models at the same time through the model class. Define model 1, model 2. You can use those methods on multiple models at the same time. Within the HyperMesh 25.0 release, we're looking at approximately 99% of our modify functions from the classic TCL API. Those are covered up to 99%. There's another 98% of the query functions that we're covering so far in this release, and we're closing that gap with every release. So the main principles of this HyperMesh Python API is we are mapping different entity types, or rather, the ways in which we handle data from TCL to Python. And these won't be exactly the same. So some things to make note of. The entity types in TCL, think elements, nodes, properties. These are now Python classes. The entities themselves are now entity objects. The data names associated with each entity are now entity attributes. Entity marks are collections, and then both the modify and query commands are organized into model methods. Let's take a quick look at a code comparison between TCL and Python and talk about some of the subtle differences. Of course, the first thing we'll need to do when operating with any Python script is import the appropriate libraries. In this case, we'll import HM as well as hm.entities as int. This brings in the entity classes. We'll define our model object from that model class as well as our property. So property is of the class int.property, referring back to the model as well as assigning a new name on when we generate this new property. The property object, prop is an object here, we can modify its card image to pshell, for example, with the dot here, so that the attribute card image of the object prop is now equal to pshell. We can do the same thing for other attributes. We'll call it pshell_t is now this float we can define new materials. We can assign the attribute material ID equal to the object of this new material that we've created. For collections of objects, we can say that comps, this is now an object that represents a collection of other entities. In this case, the collection is from this particular model of the entity type component. We can then assign the field property ID and its corresponding prop to these components with comps.setItems. Lastly, we can operate on the model with the model method scale mark and then provide different arguments like components, the distance in X, Y, and Z, and then the reference node, in this case, node 1 from this model. Lastly, we have the model query model.hm_getMass from these components. The queries return two different objects. So we have the status of the query as well as the results. We can then view the result attributes, total mass, total volume, total area, with a quick print statement. Some key points with the modify methods is that one, all of the argument names for a particular model method are mapped from our TCL documentation. So the argument names are identical between the TCL star translate mark and the Python model object dot translate mark. The specific argument types, one moment. Oh, yeah, so some of the commands like star create vector, this may not exist anymore because now we can just create the vector from, int dot vector and then define which model it's in and, an ID if we want, for example. The entity type and mark ID, that combination is now a single argument in Python. So the collection object defines both the entity type as well as the IDs of that entity. For our query methods, like I mentioned, these will return a status and a result object. And each one of those, for example, result has attributes of total mass, total volume, total area for this particular query command. I'll demo in a moment, but we have two nice third-party tool support through both Notepad++ and Visual Studio Code. I'll show you guys how we can find this HyperWorks PyAPI in Visual Studio Marketplace here in a moment. Lastly, our documentation. I'll send out a link to this as well, but you'll find that on our help and has some great references for how we structure our entity classes, how we define the HyperMesh functions, and then as always some great examples. Let's go ahead and jump into the HyperMesh client and talk a bit about some of these demos. So we have an extension that you can load with Python demos. You'll find these at community.altair.com. If you search for PythonAPI demo package, you'll get this extension, which will have some good examples in both the HyperMesh ribbon as well as Hyperview and Hypergraph. Simply download this .zip file to enable those the extension. Here in my Python demo, I'll pull up this API demo, and I think it's a great place to kind of start and understand how we access information on objects. So in this demo, it pops open an extra text visualizer on the right-hand side, and it also has opened our Python console. If you want to open up this Python console, you can come up here to View, and turn on the Python window. In this right-hand window, this is effectively the script that we just ran. So we import HM, we import the HyperMesh entity classes as int, and we also brought in pretty table as PT. In our main function here, we're defining M as that model class, and then an empty list for our property data, and then a collection of all of our properties in this model. We'll then use the Python syntax to loop through those properties for P in props. And we're just going to build up a list. So propdata.append our property name, its ID, the card image, each one of those coming from the property object and its attribute, name, ID, card image, pshell, etc. After we've looped through that, we'll build a table from pt.prettytable and get something nice like this. So here are our property names, their IDs, the property thickness if there's one assigned, as well as the material, MID, card image. So pretty straightforward. There's some other nice capabilities in here, like the Plotly web viewer. If I click on that icon, it's going to bring in a model. It will query the CBush forces off of this particular model, and it actually pulls open a Plotly web viewer on this right-hand side. So here, as this loads, I'm now looking at the queried 1D forces in this model. Let's see if I can move this around in a moment. All right, let's thinking about that for just a moment. Let's chat briefly about the Visual Studio Code interface. So from the command line, we of course have auto completion. We can also access that same auto completion from Visual Studio by coming over here to extensions. And then if we look for the phrase HyperMesh, you'll see this HyperWorks PyAPI. And once we get that installed, we'll have some nice auto completion for all of these different libraries. So HyperMesh, HyperWorks, SimLab, and then HyperWorks, which includes Inspire. If we scroll down, we'll actually see a good little animation here. So here's kind of the auto completion capabilities. Alrighty. Okay. My Plotly has updated, so yeah, as you can see, you can have, nice three-dimensional, post-queried results from these Python scripts. Let's start a new model and discuss briefly some of our developer tools. So down here in my console, I'll say clear, and let's turn on the developer ribbon here. We'll see a couple of tools within developer. There is first the task browser. Task can be thought of as a way to define a set of operations that are referred back to by TCL or Python commands. Let's open up one of our demos here. So let's get to the right folder. This will be within your installation directory for 2025. We'll have under desktop demos, software development kit, task manager, process, and grab our XML. For a particular process, all of these operations are pointing back to a Python function. If we want to take a process or a list of tasks and modify those, we can open up this process editor. Let's open that up. We'll get process set git. Each one of our tasks can correspond to a particular Python function here. So .apply config. So this task might be importing a HyperMesh model or pre-enter or post-run. So all of these are referring back to Python functions. We build off this process, and then you can have a nice little workflow through the browser. So that's more on the deployment side. Let's talk a bit about command recording. So I can turn on this recording option here, and then let's say start recording. I'm going to create a new property here. So I'll say this is, I'll just call it steel underscore 0.1. Let's generate, or first let's assign a thickness. I'll make this 0.1, and let's create a new material as well. So I'll call this steel. I'll give it some values, and then let's go ahead and stop this recording. Once I've stopped my recording, what I will see is, let's make this just a bit bigger. So these are all of the recorded functions that I just did. The first was creating an entity. So this was, creating a property entity with a card image P shell. It had a name of property 1, but then I overwrote that with an attribute modification, setting that to steel underscore 0.1. And I also modified the attribute P shell T to the float of 0.1. We did the same thing down here, create the material, assign an ID, give it a name, yada, yada. Oh, actually, yeah, this account attribute modification is assigning this material ID back to our property. Let's take a peek at parameters now. I don't have any currently, but I can add those. Let's say this is thickness, and I'll give this a value of 0.15 or something. And I'll make another, and I'll call this E, and give it like 1.5 E6. Once I have some parameters defined, I can assign those to specific objects here, or sorry, actions. Let's say my attribute modification for P shell T is now the thickness variable, and I want E to be E. Once I've done this, we can generate the code based on these recorded functions, and we can output those to either our Python console or a Python file. We can also generate verbose code, i.e. give it extra comments, show the equivalent TCL commands in the Python printout. All functions, this would mean that, actions like moving the view, the undo or redo operations, or other functions like that would also be included. Let's go ahead and click generate here. And what we should see down here in our Python console is the updated, or sorry, rather the, the recording of these actions. It's defined as a function run, and it's taking in those two variables we defined. So we have our thickness and our E variable. Let's go ahead and copy this, and I'll just paste it back into my console. Run that. And now that I've defined the function run, let's go ahead and type that in here. So I have run, open parentheses, and it expects two arguments. So float and float of thickness and elastic modulus. Let's give this, let's say like 0.2, comma 1.6 E6. If I do this right now, I already know I'll get an error because we are repeating this name. So I'll go ahead and just start with a new session. So we have a brand new model, I'll say don't save. And then I can still run this function, hit enter. And now if I check my model, I have one new property with the name steel underscore 0.1. Unfortunately, I've hard coded that name to 0.1, but you'll see that the thickness field is matching that argument that I'd provided of 0.2. And we also have a new material where the elastic modulus E is 1.6 E6. So that's a quick overview of the developer tools. So we have our process editor as well as the command recording. Let's jump into our documentation briefly. Alrighty. Actually, let's talk about how we get here. So from my HyperMesh window, I'll go ahead and hit the F1 key. This will bring up our 2025 help. And once this gets loaded up, if I take a peek at the browser on the right-hand side, or rather our table of contents, down here towards the bottom, I have our developer tools. And as you'll see, we have our task, our process editor, and our recording, like we just covered. If I go to recording, and then here I have my Python API reference guide. This link will bring you back over to this Get Started guide for all of our Python API. You'll see from the Get Started, we talk briefly about the different libraries you might want to import, how to access this Python window, as well as some example scripts. To run the Python scripts, you can either load them through file, load, and then select your Python script. You can drag and drop a Python script into that graphics area, or you can use the Python console and say run file name. Oh, it looks like we also might, so we mentioned here, you can launch those Python scripts from extensions as well by linking those to actions in your ribbon, your pull-down menu, or your toolbar. Alrighty, so we have different sections of help for the different ways in which we'll deploy the Python API. So we have one that's handling just framework type commands. So that's the HW module, and this handles the actions like animation or the color of your font or your pages and sessions within the HyperMesh interface. There are also two great functions down here, eval HWC, or HyperWorks Control Language, and eval TCL. These are some excellent intermediate solutions for any gaps in the Python API. For example, if you have a TCL script that you need to run, but you don't want to convert that to the Python syntax, you can use hw.evalTCL and then source that particular script. So this is a way to bring in that functionality to evaluate TCL commands from this Python API. Within the HyperMesh section, you'll find a great little user guide on how to get started with the entity classes, define entity selections via collection, command recording, examples. I like jumping into the examples first. This is the way that I learn, is by just looking at other examples. I'd highly recommend checking out these, as well as the examples within the HyperView section. HyperView, we've actually categorized these by their different functions. So do you want to display results and query them? Do you want to make some annotations? Do you want to do some interactive selection or work with other tools? Lots of different ways to work with HyperView and HyperGraph. Here under More, you'll find the Task Manager section. And again, this talks about the process set get, like we discussed earlier, from that XML structure. Last but not least, I like to show this report package. So we now have Python API to generate our PowerPoint reports as well as Word reports. So if we check an example here, we can take either one of these two, copy paste this into the console, and we're off to the races. One of the demos I didn't show just yet, but that I like to wrap up with, is the Python demo for this part PowerPoint report. So if I click on the demo here, it'll start a new model. It imports the CAD for us. And once it's done, it says, by the way, it's got a pop-up here, the CAD assembly has loaded successfully. Great. So once we say proceed, it's going to run a part match operation where it's grouping parts by geometric similarity, and then ask me for an output folder. So let's get over here, make a new one. I'll just say that this is demo. Grab the folder and then say select. Now what it's doing is cycling through each one of those parts set, generating images and collecting those into a report. If we take a look at the Visual Studio code, what we'll see is here we've got that function that I mentioned, PowerPoint report, PPT report, where we're selecting the folder and then running that. Where did that function go? There we go. So yeah, for each part set that's identified by this group matches model method, we are grouping this together and then make a little PowerPoint. And I think it's wrapped up for me. There we go. So let's look at the PowerPoint. So for every part that was matched with our classification tool, it's looping through those together. It gives you a quick snapshot of each one of those. And then we move on to the nuts and finally back down to our structure. So these two are identified as geometrically similar. We've got the two beams and then of course all of our washers. Alrighty. Well, thanks everyone for attending. I hope this is a great introduction to the HyperMesh Python API. We'll have trainings coming up on those shortly. Reach out to your local Altair rep if you would like to get engaged with the Python API. Thanks.